Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have completed linear programming. Hope it was clear for you all. In today's session, we shall begin a new chapter, that is probability. Let's move on to the topic. First of all, from the chapter probability, let's recall what we have learned so far. Probability is the measure of uncertainty of events in a random experiment. So here we have learned in class 11 that probability is the measure of chance or uncertainty of events in a random experiment. And here there are two terms we must be familiar with, that is random experiment and another one is events. Random experiment means the result of an experiment which cannot be predicted beforehand. An experiment, if the result is not or cannot be predicted beforehand, then we can say that that experiment is a random experiment. And random experiments, we have learned some examples: tossing a fair coin, rolling of fair dice, etc. And sample space, results of random experiment. What are the possible results we get from the random experiment? By collecting all, we will form a set, that is sample space. Usually we represent by using the letter capital S. Next is events. Events also we have learned. Events mean subsets of sample space. So sample space we used to write by collecting all the possible outcomes of the random experiment, and the events we will make by collecting the elements from the sample space. And we have learned the normal probability formula. P of A is equal to N of A divided by N of S, and P of A union B is equal to P of A plus P of B minus P of A intersection B. And we also learned P of A complement is equal to 1 minus P of A. There are some other terms we have learned in class 11, that is mutually exclusive events, exhaustive events, and some other formulas. So it is better if you revise all these formulas. It will be useful for you. From the probability chapter, first we must learn about conditional probability. Here we can split it into two. First one is condition, another one is probability. We have just now recalled about how to calculate the probability of simple events, that is probability formula, favorable number of outcomes divided by total number of outcomes. Here, not the simple probability it is mentioning, it is about the conditional probability. Let's define it first. Conditional probability is a measure of the probability of an event occurring given that another event has already occurred. This can be considered as the condition because one event is already occurred. Then we have to find out the probability of the other event after occurring the first one. That is what the conditional probability. For getting more clarity, let's take an example. There is a situation. Let's think of a situation. A family has two children. There are two children in the family, and the possibilities are sample space. We can say S is equal to girl, girl. First one is girl, second one also girl. First one is a girl, second one is a boy. First one is a boy and the second one is a girl. Both are boys. And here, let A be an event. That means A already we know something, that is the condition here, already occurred. Means there is a girl in the family. We must know that there is a girl in the family. There is a girl, one girl in the family, already we know. Means A is equal to, the event A is equal to, if there is a girl in the family means this possibility is gone. That means both boys cases are not there because already there is a girl. That means both boys will not be there. So the remaining possibilities will be coming here, that is GG, GB and BG. Next one is B, both the children are girls. Next event we are taking, both the children are girls. That means from here both the children are girls in the sense there is only one possibility, that is G and G. Here A we have taken as an event that there is a girl in the family. That is already happened. We must know that there is a girl in the family. That means the outcomes are like this. And the second one is both the children are girls. That means this is the outcome. Now probability of B given A, in the sense probability of both the children are girls, given that A in the sense the first one is a girl. Probability of both are girls given that the first one is a girl. So read by probability of B given A is equal to, the formula is there, P of A intersection B divided by P of A. P of A intersection B in the sense, you can see there A and B, when you consider A intersection B is this one because it is there in both the sets. So set of GG. Then P of A intersection B in the sense there is only one element. Total elements in the sample space there is 4. So 1 divided by 4. Next one is P of A we have to calculate. P of A in the sense A there are 3 elements and the total number of elements in the sample space is 4. So 3 divided by 4. That is P of B given A is equal to P of A intersection B we have calculated. We'll put that is 1 by 4 divided by 3 by 4. So 4 will be cancelled. The final answer P of B given A is equal to 1 divided by 3. So this is the way we calculate the conditional probability. Means here P of B given A in the sense probability of both the children are girls given that the first one is a girl. So let's define the conditional probability little more clear way. That is, if E and F are two events associated with the sample space of a random experiment, the conditional probability of the event E given that F has occurred. The conditional probability of the event E given that F has occurred is P of E given F. We just write P of E by F, but we read as P of E given F is given by the formula P of E given F is equal to P of E intersection F, the intersection probability of the intersection of these two, P of E intersection F, divided by P of F. What comes after given, that will come as the denominator, provided P of F not equal to 0. So when conditional probability comes, here you can see A is equal to set of GG, GB and BG. And here when you compare with the sample space, once a particular thing is already happened, then this sample space will reduce to this one. So you can see here this sample space after there is a girl in the family means this BB is gone. Means the sample space is reduced to 3 elements GG, BG and GB. And both the children are girls in the sense probability B is equal to set of GG. And when you calculate probability of B given A in the sense, you can see here directly we can calculate by using these two. This will considered as this can be considered as the sample space. So you can see their intersection, that is GG, there is only one element out of these 3 elements. So P of B given A is equal to 1 divided by 3. Next we shall discuss the properties of conditional probability. Here we have to discuss about 3 properties. Let E and F be events of a sample space S of an experiment. Then we have first property, probability of S given F is equal to probability of F given F is equal to 1. Here S is a sample space and F is a subset. Probability of S given F is equal to probability of F given F is equal to 1. This is the first property. Let's see how this property is derived. Probability of S given F is equal to, by using the conditional probability definition, we can say that the probability of S intersection F divided by probability of F. Since S is a sample space and F is a subset, S intersection F, this can be considered as a universal set by using set theory. So S intersection F, surely it is F. So P of F divided by P of F, denominator is P of F. So P of F and P of F can be cancelled and we will get the answer as 1. Next is P of F given F. P of F given F is equal to, by using the conditional probability formula, P of F intersection F divided by denominator, that is P of F. Here also F intersection F means P of F only, divided by P of F is equal to 1. So we can come to the conclusion P of S given F is equal to P of F given F is equal to 1. Second property, if A and B are any two events of a sample space S and F is an event of S such that P of F not equal to 0, then here you can see A and B are any two events of a sample space S and F is an event of S. So these are the condition, and P of F not equal to 0. Then P of A union B given F is equal to P of A given F plus P of B given F minus P of A intersection B given F. Once again, P of A union B given F is equal to P of A given F plus P of B given F minus P of A intersection B given F. Let's see the derivation. P of A union B given F is equal to, by using the conditional probability definition, you can say P of E intersection F is equal, P of E given F is equal to P of E intersection F divided by P of F. Same way, P of A union B given F is equal to intersection of these two sets. P of A union B intersection F divided by denominator, that is P of F. Then P of A intersection F union P of B intersection F. This can be removed, that is by using the formula A union B intersection F is equal to A intersection F union B intersection F. This formula you have studied in class 11. A union B intersection F is equal to A intersection F union B intersection F. That's what it is written. Divided by denominator is P of F. Then here P of A union B format. P of A union B we have learned P of A plus P of B minus P of A intersection B, distributive law. So when you split it, P of A intersection F, it's written here, then plus P of B intersection F, it's written here, minus intersection of these two, that is P of A intersection B intersection F. So that is written here, minus P of A intersection B intersection F divided by the denominator, that is P of F. We can just write the reason as the distributive law, then we can split the denominator, that is P of A intersection F divided by P of F, P of B intersection F divided by P of F minus P of A intersection B intersection F divided by P of F. When you see the first one, it is quite clear, it is a conditional probability, that is P of A given F. Next one is the probability of B given F. Third one is the probability of A intersection B given F. So first one is P of A given F, next one is B given F, third one is A intersection B given F. When A and B are disjoint sets, you know that disjoint sets means there will be no intersection, no common elements, means this will be 0. That is P of A intersection B given F is equal to 0. So P of A union B given F is equal to, only reduced to this one, P of A given F plus P of B given F, provided A and B are disjoint events. Property number 3, that is P of E naught given F is equal to 1 minus P of E given F. Once again, probability of E naught given F is equal to 1 minus P of E given F. Let's see the derivation. P of S given F, we know that it is 1. It is learned from by using property 1. P of S given F, S is a sample space, F is a subset. So P of S given F is equal to 1. Then P of E union E naught given F is equal to 1. P of E union E naught, that is E union E naught is S, a complement of two set, that will be surely a sample space. So P of E union E naught given F is equal to 1. That is P of E given F plus P of E naught given F by using this formula, that is P of A union B given F is equal to P of A given F plus P of B given F, provided A and B are disjoint sets. Surely E and E dash are disjoint sets because there will be no common element, because one is a complement of another one. So we can write it as P of E given F plus P of E naught given F is equal to 1. Reason, E and E dash are disjoint events. So from here we can write P of E naught given F is equal to, this can be taken to the right side, that is 1 minus P of E given F. So this is the property number 3. Next we shall discuss the exercise questions. First question from exercise 13.1. The question is, given that E and F are even such that P of E is equal to 0.6, P of F is equal to 0.3 and P of E intersection F is equal to 0.2. Find P of E given F and P of F given E. So simply a direct question. Let's write down the given condition. P of E is 0.6, P of F is 0.3, P of E intersection F is 0.2. We have to calculate P of E given F. Formula we have to write P of E given F is equal to P of E intersection F divided by P of F. So P of E intersection F is given to us, that is 0.2 divided by P of F is given to us 0.3. So when you divide it, or you just multiply 10 in the numerator and denominator, it becomes 2 divided by 3. Second question, that is second part of the question, P of F given E. So P of F given E is equal to P of E intersection F divided by P of F, this one. Sorry, P of E, this is the one. So P of E intersection F divided by P of E. That is equal to P of E intersection F, we know that it is 0.2 divided by P of E. P of E is 0.6. As before, you can just multiply 10 in the numerator and denominator. It comes as 2 by 6. And again, there is 2 common in both numerator and denominator. We can cancel it. It comes as 1 divided by 3. Second question, compute P of A given B if P of B is equal to 0.5 and P of A intersection B is equal to 0.32. We are asked to calculate P of A given B. So given conditions we have to write P of B is given to us 0.5 and P of A intersection B is given to us 0.32. That is, what we have to calculate is P of A given B. P of A given B is equal to P of A intersection B divided by P of B. From the formula directly we can write, that is P of A intersection B is 0.32, that is given to us from the question, and P of B, that is 0.5. That is equal to, when you multiply it in the numerator and denominator by 10, so you can, 100, you can just, it will come as 32 divided by 50. 32 by 50, when you just cancel 2, it will come as 16. 32 divided by 2, that is 16. Divided by 50 divided by, that is 25. So 16 by 25. You can directly do it as a mental calculation, or if you feel difficulty, just do it in a piece of rough paper. That's all. Next we shall discuss question number 3. If P of A is equal to 0.8, P of B is equal to 0.5 and P of B given A is equal to 0.4, find there are 3 sub-questions, P of A intersection B, P of A given B and P of A union B. First of all, let's write the given things. P of A is 0.8, P of B 0.5, P of B given A 0.4. Here, first we have to calculate P of A intersection B. For that, we need to take this one, P of B given A, because P of A is not carrying A intersection B, P of B also not carrying A intersection B. So, but P of B given A formula carries A intersection B. So, let's take that one. P of B given A is equal to 0.4. Formula we can write P of A intersection B divided by P of A, denominator. P of A is equal to 0.4. Substitute it. P of A intersection B by P of A is 0.8 equal to 0.4. When you cross multiply it, P of A intersection B is equal to 0.8 into 0.4, that is 0.32. Next one, P of A given B we have to calculate. Write the formula. P of A given B is equal to P of A intersection B by P of B. That is equal to P of A given B is equal to P of A intersection B. P of A intersection B we have calculated and kept here, that is 0.32. 0.32 by denominator is P of B. P of B is 0.5. Since here all calculations are in decimal form, you can just divide and write the answer in decimal form, that is 0.64. Then third part, that is P of A union B. There is a formula we have just recalled. P of A union B is equal to P of A plus P of B minus P of A intersection B. All values are there, substitute it. P of A is 0.8, P of B is 0.5 and P of A intersection B is 0.32. When you do the calculation, it will come as 0.68. Then question number 4. Question is, evaluate P of A union B if 2 P of A is equal to P of B is equal to 5 by 13 and P of A given B is equal to 2 by 5. Here two conditions are together, it is given to us. Let's take that one. 2 P of A is equal to P of B is equal to 5 by 13. Let's split it. 2 P of A is equal to 5 by 13. Then from here P of A we can calculate. P of A is equal to 5 by, this 2 will come here, that is 5 by 26. 2 into 13, 26. P of B, it is clear for us, 5 by 13, right as it is. Then for calculating P of A union B, we know the P of A union B formula. This is the one, P of A plus P of B minus P of A intersection B. P of A, P of B is there, but A intersection B is not there. For that only this condition is given to us. Let's take that one. P of A given B is equal to 2 by 5. P of A given B formula, P of A intersection B by P of B is equal to 2 by 5. Substitute it. P of A intersection B is equal to this P of B I am taking to here. Cross multiplication, that is 2 by 5 into P of B. Why I am multiplying this one to cross multiplication, or why P of B is taken to this side, in the sense P of B is a fraction. Here when you can see here P of B is 5 by 13. When you put 5 by 13 here, it comes as denominator's denominator. One more step will be coming. That's why we are taking this one to here, and then when it reach here, just multiply it. 2 by 5 into 5 by 13. So 5 cancel, you will get the answer as 2 by 13. So this is P of A intersection B. So now all the things are ready. P of A is there, P of B is there, P of A intersection B is there. So we can now calculate P of A union B by writing the formula P of A plus P of B minus P of A intersection B. Yes, I substitute it. P of A we have 5 by 26. P of B we have 5 by 13. P of A intersection B we have 2 by 13. Substituted. Take 26 as LCM. That means here 5 only will be coming. Here 2 will be multiplied. So 2 into 5, 10. Here also 2 will be multiplied. That is 2 into 2, 4. That is equal to 5 plus 10, 15 minus 4. That is 11 by 26. So P of A union B we have got as 11 by 26. Next, move on to question number 5. Question is, if P of A is equal to 6 by 11, P of B is equal to 5 by 11, and P of A union B is equal to 7 by 11, find first one P of A intersection B, second one P of A given B, and third one P of B given A. So try this question as homework. Dear students, today we have started a new chapter, that is probability, and we have learned a topic, that is conditional probability. I request all the students to go through the textbook and read the textbook properly, so that you will get a clear-cut idea about the conditional probability. Hope it is clear for you all, and if you have any doubt regarding this topic, please note it and keep. We will discuss it during the discussion session. Thank you for watching.